Okay, I want to demonstrate the non-existent law of averages. And what I'm going to do is I'm going to simulate a coin toss. So right now, what I'm going to do is I'm going to call getting tails is going to be my event. And I'm going to signify that by the number 1. Heads is the other possible outcome, and I'll signify that by 0. Now, the idea behind the law of averages says the following. If you see a particular streak occur, in order for the proportions to even out, you will need to have more occurrence of another event. In this case, we only have 2 possibilities, a tails and a heads, to make life simple for us. So first, let me just run a quick little simulation. I'm going to go into data analysis, random number generator, and I'm going to do this. I'm going to do this once. It's going to be simulating tossing a coin, let's say 10,000 times. I'm going to choose a distribution called Bernoulli. Bernoulli is a type of distribution in which you can only get a 0 or a 1, nothing else. And the parameter is the chance of getting a 1. So right now the chance of getting a 1, which signifies tail, is 50%. So I'm assuming it's a fair coin. Again, my random seed, I'm going to choose a number between 0 and 32,000. Since this is a pseudo random number generator, I'll choose 2. Now, you know something? 29. I'm going to select here output range. I'm going to put it here in A1, A11. And I'm going to hit OK. Okay, and there it is. My first coin outcome was a tail, followed by a head, then tail, 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 then head, tail, tail, head, tail, tail, head, 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 tail, head, and so on. Now I'm going to do the following here. So what I'm doing is I'm going to add up the column, but I'm going to do it starting at A11 and working my way down. Since my numbers are just zeros and ones, the only thing that would really be counting is every time I get a 1. So as I keep summing up, if I have a sum of 7, that means I have 7 tails. The count, however, will just tell me how many times I'm moving down the list. So for example, if I get a sum of 7 and a count of 20 means I've actually observed things 20 times, of which 7 of those resulted in a tail. So when I hit return right now, all that's going to happen is I'm going to get a sum of 1. The first observation is a tail, or it's 100%. Right now, I'm observing 100% tail. If I now work my way down, well, it didn't come out right. Oh, 1 second. Need to change one little thing here. Forgot my $sign here as well. I need to keep this one fixed. Missed the $sign. Let's try this again. So when I move to the next one, it goes down to 50%. Okay, so in other words, half the time now I'm getting a tail. Go to the next one. Now it's 2/3, or 66.6666%. In other words, out of the 3 coin tosses, I observe 2 tails, or 2/3 of the time. Now move to my 4th. Now 75% of the time I've experienced a tail. 80% of the time I've experienced a tail. Back to 66% of the time. But again, this is a very short run. I'm interested in the long run. So I keep going in this fashion. And I think I did this 1,000 times or 10,000 times. So I better speed it up here. Here we go. I just noticed by the time I get to observation 6,441, I'm almost at 50% where I should be. Let's create a visual of this. Um, 100%. Then on my second throw is again hard to see because it's so crushed up. It's somewhere it went down to 50% mark. Um, and as I kept tossing, there was a lot of variability at the beginning. Notice this is below 1,000, but at a certain point, the thing starts to die out. And where's it dying out to? Well, here's the 50% mark. What is the law of averages? All right, here, let me demo it now. I'm going to create a very bad scenario. I'm going to insert, looks like maybe it was like 400 or 500 rows here. Hang on. Okay, there we go. But what's about to happen? I'm not going to do this randomly now. I'm going to create the scenario where I just, for some bizarre reason, get a tail. And then I get another tail, and another tail, and another tail. In other words, from now on, however many rows I've created, here we go, look at that, what a mess. Oh, there we go, past it, past it, past it, past it, past it, past it, there we go. So for 480 observations, it's just for some reason it came out tail, 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 tail. Now, you ask yourself, well, how am I ever going to get back to the 50%? It must mean that I need an equal number of heads. In other words, bet heavy on heads because it's got to come up now. And let's say this is completely random. This is not cooked up. That's for some reason, 480 some tails appeared randomly. Again, another astronomically small probability. But the point is, will I now need to get another large set of heads? In other words, will heads come off more often so the whole thing goes up to 50%? And the answer is no. You'll notice that this, I'm going to use exactly what was here before. I'm just going to copy this, head back to the top again. Again, notice I'm getting a 1 and a 1 again because it's 100% after all. Okay, so right now it's all tails, so 100% of the time I'm getting tails, but now let's just keep going. I mean, the thousands, 2,000 observations, 3,000 mark, 5,000 mark, 5,000 mark. Yeah, this I'm going to keep going. I'm going to go all the way to the 10,000 mark. I stopped last time at about 6,000 something. My God, how many did I do? I thought I only went to some 10,000. Oh, there we go. Oh, that's right. I've had it 493. Oh boy. Okay, so I'm about to let go of the button. The final number you see at the bottom here will be the proportion up to this point after some 10,480 some observations. So will it be 50% or something else because my first 480 some observations were just tail? The answer is it's thinking. Oh, suspense. I should have been talking while this was going on. It's thinking. It's thinking. 50%. So what happened here? How could this be? After all, I had an amazing streak of tails. Shouldn't I have gotten more heads? No. No, as a matter of fact, you notice the last 10,000 so rolls was under the 50-50 mark. The first 480 were not under the 50-50 mark. But think about it. All that's happening is the other 10,000 some rolls are on the 50-50 mark, drowning out the original 493. I'm still arriving at my 50% mark. I'll arrive a little late, but I'll arrive there. It doesn't really matter. As a matter of fact, now when I go back up, let's see, how long did it take me to reach that magical around 50%? A lot shorter than you think. Notice around the original 700 some mark, I'm already down at 52%. It's already dying down. Notice there's a little rise up, right down, but I'm dying. Notice right here at 855, it's down to the 50%. Then it rises up a little again. Again, it's fluctuating, but each time it's fluctuating towards the 50%. So it doesn't take that long. And that's why the law of averages doesn't exist. We're also making one other huge assumption, this concept called independent. We're assuming that each observation is independent of the other observation. Now, what does independent mean? This is a tricky one, and one that you probably will struggle with, but the explanation is quite simple. Independent just means that my probability for a particular outcome does not change. In this case, from observation to observation. So as I keep tossing this coin, I always have a 50% chance of success. If that's the case, we have independent. And again, there's no such thing as this law of averages. So if you're gambling, and there's a 10% chance of you winning, and you've lost many, many times, are you due to win? No. Your chance continues to be 10%. Why is that the case? What does your intuition tell you otherwise? Here's a reason. If you were to tell me you were going to walk into a casino and you're going to play a particular game, which you really don't have a high chance of winning at, but you ask me, in 1,000 attempts, will I win? The answer goes, oh yeah, I know you'll most likely will win at least a few times, depending on what the real odds are, but you'll win. But see, nothing has happened yet, so you're telling me something that's about to happen in the future, so I know that because it hasn't happened yet, I'm predicting a future outcome, that you haven't played anything yet. So I mean, I know you'll have to win sometime. That I'm pretty assured of, depending on the odds, but I'm pretty assured of that. But once you've played, that's it. You have played. It's over. The outcomes are done. What's in the past is in the past. The future is brand new. So there's no recalling. I don't know if that makes sense. But we don't have to, you don't have to overcome past experience. There's a new future ahead. That's it.